Hello everybody. So this is just going to be a supplement to the previous lecture. So coming up with the equations for a given secant or cosecant graph was hard. And so I want to try to just do a quick video where I just show you kind of the easiest way to do it. Okay, so we want to find equation for a given graph. That's not a color. This is a color. So we want to find the equations of a given graph for a sine, or sorry, for a secant and a cosecant. We'll do the cosecant first. No, we'll do the secant first because the secant is easier. So the equations that we're going to be looking at are like a secant bx minus c like this, or a secant b parentheses x minus c close parentheses plus d. Now, it doesn't really matter which one you do, but for secant, it's going to be easier to do the second one, and so we'll do that. And for the cosecant, we'll probably do the first one because that's what will turn out to be easier. Okay, so I've got a problem over here, and this is the one we're going to try, if I can. Well, if I can type it in, hold on. Let's just do continue. Is that... Yeah, that's secant. Okay, so we'll do this one. So we got a point on here that we can see 1/3 pi 3/2. 1/3 pi 3/2. I'm just going to write that. 1/3 pi 3/2. And the other one was 13/3 pi. 13/3 pi. All right. Now, I'm going to exit this. I'm just exiting it to try to make it save it so it doesn't delete what I just wrote. And then I'm going to close this because I want it to go fast again. Okay, there we go. So on the graph, what that looked like was, let's see, they're up at 3/2. So I've got 1/3 pi and 13/3 pi. So I guess I better go here, and we're going to call that pi over 3 3/2. And then that's 1, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's lucky. Right there. And that'll be 13 pi over 3. Is it really 13? That's kind of not a good number. All right, is what it is. So we have those numbers, okay? And then in between, we really don't know what the graph looks like very much, but we've got what do we have? Oh, they go down from there. Okay, so from here, this is going to go down this way, and then down this way, and then down this way, and then on the other side goes up, and the highest it gets is 2.5. I see. Sorry, the lowest it gets is 2.5. What I'm saying is, if I take this out of the way, then up at 2.5, so this is supposed to be 3/2. So 1.5 is, I don't know. I'm not going to draw this to scale, okay? So I'm just going to call this 2.5. Then somewhere in there, there's in the middle, you have one goes up like that. Okay, and I'm not going to draw it very well, but that's what we have. Okay, now what I want to do then is we want to talk about each of these things, the A, B, C, and D. So the A is not the amplitude, but it's going to be basically the vertical scale. All right, and the way you get that is you know what the normal gap is between these, right? Because like right here, between this line and then this line, there's nothing, right? Like all of this is empty. And so that distance here it's from 3/2, which is 1.5, up to 2.5. So 1.5 to 2.5, that's a distance of 1 here, right? So that gap on this one is 1. On the normal secant graph, it's 2, right? So normally it's 2. On ours, it's 1. So in order to go from 2 to 1, then it must be compressed by a factor of 2, or just half as tall, right? It's half as tall, basically. So the gap is 1. On the normal secant, it's 2. So our graph is half as tall. 1/2 as tall. Okay, that tells you that A is either 1/2 or minus 1/2. Okay, you can't tell just from knowing that that gap is like that that it's 1/2 or negative 1/2. But what you can do is, if you look at the original secant graph, which I'm going to draw a little bit of, the original secant graph looks like this. Oops. I don't know why I drew that there. That's in the wrong place. Whoa. Okay, so that's the normal secant graph. This is y equals secant x. So a couple things you can see here. So this is at 1, and then this is at minus 1. And so one thing you can see is that gap that I told you about, right? From here to here, that height is actually 2, right? So that's the 2 that I'm talking about. But the other thing is that you can see that in the middle, like around the axis, right? Like this is the y-axis. You've got this, right? Right in the middle, and it's pointing up. Whereas on this graph, close to the middle, you have this one, and it's pointing down, right? So by comparing, you can see that our graph is upside down compared to the original. So since ours is upside down, we actually want A is negative 1/2 instead of positive 1/2, right? Because a negative out front flips it upside down. Okay, so the next thing that you want is you want the B. So the B comes from the period. Right? And you know the relationship B is 2 pi over B. That's the same as the one for sine and cosine. Now, in order to get the period, we're going to measure it from our graph. So we measure P on the graph. So you have to go up to your graph and say, well, what's 1 period? And so 1 period on your graph is from the is basically the 2 points that they gave you. So from here over to here, that's 1 period. Because that's how far you go before the graph repeats itself. So it's pi over 3 to 13 pi over 3. So you're going to do 13 pi over 3, the one on the right, minus pi over 3, the one on the left, and you get 12 pi over 3, which is 4 pi. That's the period. Okay? And that's what P is. So you take that number and you put it in for P. So plug in to the equation and you get 4 pi is 2 pi over B. So 4 pi B is 2 pi. So B is 2 pi over 4 pi, which is 1/2. So then we have the B. The B is 1/2. Now the D comes from the midline. Or it's the vertical shift, if you can just tell it. Right? So you have to look at your graph and say, well, normally the midline is at 0. And so how far has this been moved up or down? And so what you would want to do is you'd want to say, well, you have to look at, it's a little bit tricky to see here, but this is up at a height of 2.5. And the bottom one is down at a height of 1.5. So the middle is at 2, isn't it? 1.5, 2, 2.5. So the middle is at 2. So the middle's at 2, so that's the midline. So D comes from the midline, so we're up 2. You just read it off the graph. Okay. Now the hard one, normally the hard one is the phase shift. Okay. So the phase shift is the hardest to get. So for the C, what you're going to do is this. So this works for the secant, but it doesn't work for the cosecant really. So just comparing these graphs here, right? Normally on the secant, there's one of these pieces, one of the pieces of the secant is in the middle at x equals 0, right? And then in your graph, it's moved, right? Normally, on the secant, you have a piece like this, right? We just need to see how far it's been moved left or right. The C is how far it gets moved left or right. Okay, so on ours, what we're looking at is this piece right here. So I've got a piece that looks like, why up at 3/2? Why did I put that there? That doesn't make sense. There. So on ours, you've got a piece that's like this, and the point is labeled pi over 3, comma 3/2 or something. Well, just comparing these, right? This one's at 0, 1, and the other one's at pi over 3, 3/2. So you should be able to see that the point's been moved to the right by pi over 3. So right by pi over 3 is what has happened. Okay, so that tells you that the C is, well, it depends on how you write it. If you're using the form that I have here, then that would be a pi over 3, the way that I wrote it. So at this point, I have the A, the B, the C, and the D. So I just need to write the final thing. So I have y equals A secant, B parentheses x minus C plus D, and we put in all the numbers. So the A is negative 1/2, upside down and half as tall, secant. The B is 1/2. That'd make it twice as wide. X minus C, C is pi over 3, because the whole thing's been moved over pi over 3, and then the D is 2, because it's all been moved up by 2. So you can either type it in like that, or if you multiply that 1/2 through, you don't have to. You could type it in like this as well, and that would be fine. So let's see here. Negative 1/2 secant negative 1/2 secant. How do I get the, you're supposed to let me type in trig. Okay, you're not going to. Secant, basic, parentheses. I believe we had 1/2 x, I think it's minus pi over 6, but we're going to have to check it anyway. Minus pi over 6, and then plus 2. Plus 2. Now, if I got this wrong, then I'll just fix it. We're not starting over or something. Okay, we got it. All right, and so that wasn't that bad. I mean, it's kind of bad, but it's not impossible. All right, let's go back here and see if we can get a cosecant now. Oh, it's another secant. I don't want to do another secant. Cheat. Submit. Continue. Oh, it just finished, didn't it? So it's not going to give me one. All right, I'm going to have to make one up for the cosecant. All right, so for the cosecant, I would recommend that you use this form. So the difference is that I don't have parentheses around the x minus c there. And there's a specific reason why I'm doing that, and it will come up. Okay, so we can only do this with an example. Almost everything except getting the c is the exact same as what we did for the cosecant. So the basic, sorry, the same as the secant. So the basic cosecant graph, where it comes from, right? We graphed it in the other thing. Scientific words. All right. So, right? No. Okay. Good enough. I don't really care. Close enough. So I'm going to say that that's a sine. So that's like y equals sine. And then, so you've got wait a second. So that's the asymptote. Oh yeah, that's fine, because you're not going to be able to find the asymptotes on the graph that they give you. So there's asymptotes wherever that goes through 0, and then the actual cosecant graph, right, is in between. So the purple graph is the cosecant graph. And I'm not drawing it well, but I'm not trying to draw it well. I'm just trying to get something on the page here. All right, so purple is the cosecant graph. Red is the sine. Okay, so that's a lie. They'll even delete these. Okay, so the only thing that I want here to keep track of is this is 0, right? This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. All right? And the only thing I really want you to pay attention to right now is this. The pi over 2 is where that first one is. Okay? And actually on the sine, right? That's where that is. Okay? Now, let's try to graph one of these. So, or sorry, not to graph one of these. How to come up with the equation of one of these. So, what I am going to do is I'm going to just draw some axes. I'm going to give you a couple of numbers here. I'm going to put one of these guys on here. And I'm going to tell you that this number is, I'm going to say that this is at, it could be anything, but I'm going to say that this is at, I'm going to say that that's pi over 3, comma 4, why not? And then over here, there's going to be another one, because that's how these problems work. And I'm going to tell you that that one is going to be at 4 pi over 3, comma 4. Okay. And then there needs to be another one. I'm going to put it right here, and it's going to go down. And I'm not going to tell you the number, but we know that that's 0 for the y-axis. Okay, so this is the graph we have, and we want to find the equation. All right, so you're going to go through the steps that we did for the secant, but one step is going to be a little bit harder, right? So the first thing we want to do is find the A. So in order to find the A, we need to know how tall this graph is. So you measure the distance, like basically of the gap, right? So how far is that on this graph? Well, it's from 0 to 4, right? So it's 4. The gap is 4. That's not A, but the gap is 4. That's twice as tall as normal, right? Twice as tall as normal. So if it's twice as tall, that means A is 2 or minus 2. And in fact, it's going to be 2 because just by looking at this graph, it doesn't look upside down compared to the one here because the axis, like the normal axis is right here, right? And just to the right, you have one of those right side up U shapes. And here's the axis, and right over here you have a right side up U shape. So it looks like it's not upside down. So if it's not upside down, then you take the positive one. All right, now B, we know that we're going to use P equals 2 pi over B to find the B, but you need to know the period. From the graph, the period is, well, you got to measure. So the period is from from one of these U's to the next U. So the distance is, that's one period. So one period is 4 pi over 3 minus pi over 3. So 4 pi over 3 minus pi over 3 is pi. So the period is pi, but you still have to plug that into your equation. So you've got, so you plug this in for the P, and you get pi equals 2 pi over B. So B, I'm going to cheat here, just do a little too much. B is going to be 2. So you get B equals 2. So far we have A equals 2. B also is 2. Let's get the D, because D is easy-ish. D is the midline, right? D is the midline, which you're just supposed to be able to read from your graph, although mine's messy, right? But this is 0, and this is 4. So what's the midline? It's going to be in the middle, right? So it's going to be 2. Well, did I just do 2, 2, and 2? Okay. Sorry. I mean, it is what it is. So A is 2, B is 2, D is 2. They're all 2. The C is the hardest part. Okay? And so here is, as far as I can tell, the easiest possible way to find the C. Okay? Here's how it is. We have, if you draw, well, how do I want to say it? All right. So compare these two numbers. I'm going to highlight them. So compare this, nope, yellow, compare, highlight. Normally that's at pi over 2, right? And over here it is at pi over 3, right? So what you do is, like, normally that first U shape, so normally write this. Normally, so this is for C. Normally, the U shape, the first U shape, the one that I highlighted, is at x equals pi over 2. On ours, it's pi over 3. Okay? So what you do is look at the equation with the A, the B, and the D all plugged in. So we have y equals A cosecant It doesn't matter which form you use here, so I'm just going to go like this one, bx minus c plus d. Put in all the 2's. Again, it doesn't matter that they're 2's, it just, they are what they are. This is what you get, right? We're only missing the c. So the whole key to this is this fact. Normally, it's x equals pi over 2. Ours is pi over 3. So what you do is you combine that information and you say, right here, when x is pi over 3, right? In our graph, it's pi over 3. What I circled, the 2x minus c, should be pi over 2. And that's the way you adjust it so that when you plug in a pi over 3 into ours, it's like plugging a pi over 2 into the original. And I know that that's not like, you don't have a lot of motivation for that, but it's the easiest way I could think of to do it, so that's what we're going to do. So you just like write it out, and then you have your bx minus c has to equal pi over 2. You could even just write that. You could just memorize. You could just memorize that bx minus c equals pi over 2 when you plug in that point there, that pi over 3. I'm not going to say memorize it because you need to be able to work this out. All right, so you have 2x minus c equals pi over 2, but that's supposed to happen at pi over 3. So you put the pi over 3 in for the x. So 2 pi over 3 minus c equals pi over 2, and we solve this for c. So I've got 2 pi over 3 minus c equals pi over 2, or rearranging this, I'm going to rearrange it a lot, so I'm just going to write the answer. C is going to be 2 pi over 3 minus pi over 2. I'm going to do that on a calculator. So on a calculator, I've got 2 times pi over 3 minus pi over 2, and I get pi over 6. Okay. So c is pi over 6. Then you combine all that together, and we're going to have the equation y equals 2 cosecant, and I used the form that I wrote there. So b is 2x minus pi over 6, and then I have plus 2. And that would be my answer. Now this was not from the homework because the homework finished, but there we go. So let's look at it at Desmos at least, just to double check that it matches. Close all these. Close, 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 close. Delete. All these delete. Delete all of these. Okay. So out front, 2. Inside, 2x minus pi over 6. Don't have a way to close parentheses, so just move over, and then we had, is it plus 2? I believe it's plus 2. I think that's right, 2, 2, 2. So just make sure everything's right. So notice that it is between 0 and 4 on the x-axis, right? Like down to 0 on the down to 0 on the y-axis, and then 4 on the y-axis. Does that match? That matches, right? 0 to 4. Now, then you've got this bottom right here is at pi over 3 comma 4. Check that. Is that in the right place? Is it? It's not highlighting it, but I think it is, right? Yeah, there it is. Right, you see the pi over 3 down here. So pi over 3, that's in the right place. Now what about the other one? 4 pi over 3. Is that in the right place according to my picture? Yeah, it is, right? 4 pi over 3 is in the right place. So everything is in the right place. So those are the right numbers. And what I did here is going to be the right, not the right way, but the fastest way that I could think of to find the C in the case where you're doing a cosecant. Could not think of a faster way. All right, so that's it. So it's 2.5 hours of videos for today. That's enough. See you next time.